taken me a minute, but now I finally get it. You're magnetic, magnetic, pushing and pulling me. Oh, 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 oh. You're so magnetic, right where I wanna be, right where you wanna be.
All right, so in today's lesson, we're going to be talking about magnets. So in our previous lessons, we've done some observing and some investigations on what magnets do, what magnets stick to, and what magnets don't stick to. You guys made predictions, you tested out objects, and now we want to know, why does it work? Before we go into that, let's look at this comic. I know you all know who this character is, right? So we have Iron Man, and Iron Man is ready to go fight some crime. So he's going, and he says, I've got to take down those tanks before he could do it, he gets swooped up, and he sticks to this giant magnet hanging from the air. Why does this work? We know magnets stick to things, but why would Iron Man stick to a giant magnet? So let's talk about magnets. So in the classroom and in the scientific world, we see magnets in three ways. Either as a bar magnet, right here, or we see them as a horseshoe magnet, or we see them as a ring magnet. And all of these magnets do the same things, they're just in different forms. But we also see magnets every day in things that you wouldn't expect. So when we are at home or in the community, we see magnets in compasses. They're on our refrigerators when mom and dad post our good grades or our artwork. We see them in office supplies like this paperclip holder. We see them they're in speakers. And also, maybe many of you might not know that our Earth is a giant magnet. All right. So now we know what magnets look like in their traditional form and in maybe not so normal form, but that still doesn't explain how it works. Is it magic? Nope, it's science. So how do magnets work? All magnets have a north and a south pole. They may not be labeled, but they have those two sides. On the North Pole, we have a North Pole and we have a South Pole. And when we see things that stick together, that means they attract each other. And when they are not sticking or they repel, we see a pushing action. They're repelling against each other. So two magnets that are attracted have two sides that are opposite, and those are the ones that'll stick together. So if we have a north pole on one magnet and a south pole on another magnet, those two magnets will stick together. However, if we have the north pole of one magnet and the north pole of another magnet, they're both north poles or they're both south poles, and we try to stick them together, they won't stick. Instead, it'll be like two strong forces pulling them apart or pushing them apart, right? It's a force of pushing and pulling, and that's the force of magnets. But what is this force called? This force is called the magnetic field. It's invisible. We can't see it. So many people think it's magic, but it's not. So in this picture, you see all these lines, and they're connecting to the North Pole and the South Pole. This is the invisible magnetic field that we don't see. It's all the forces that are around the magnet that allow it to attract certain things and allow it to repel other things. It allows it to pull things in and push things out, just like in this picture here. So now that we know what magnets do and how they do it, what are things that magnets are attracted to? In our experiment, we saw things like paper clips, the whiteboard, Jennifer's bobby pins, and we saw Sarah's jewelry. All were attracted by magnets. Magnets are attracted to things like nickel, iron, and cobalt. Those are 3 metals. You may or may not know what they are, but we see them in items that are everyday items. And ideally, if Iron Man is really made of iron, he will stick to a giant magnet, just like in the comic we saw earlier. So if Iron Man is really made of iron, he would look just like this one. So now we know how magics work. Is it magic? Nope, it's science.